Hello friends, today in this video we are going to see two hybrid networks going to be interlinked by the use of BGP routing protocol. In my previous two videos where I have made two network domain having their internal routing protocol as one is OSPF and in another video I made the internal routing protocol as EIGRP routing protocol and let them interconnect with the use of BGP routing protocol. But here we have taken a hybrid one, in which here we have two network domains. The first network domain is 192.168.1.0/24, which is given to the cluster number 0, and the second network domain 192.168.2.0/24 given to cluster number 1, in which cluster 0 is in ASN number 30 and the R2 is the edge router of the cluster 0, and the ASN number 50 is the ASN number of cluster 1, and the router 4 is the edge router of the cluster 1, and within it, in cluster 0, this particular network is again subdivided into two subnetworks having IP address of 192.168.1.0/26 and the 192.168.1.64/26, in which the first subnetwork is having internal routing protocol as OSPF, and in another subnetwork is having EIGRP as its internal routing protocol. Similarly, in cluster 1, this network domain is subdivided into two subnetworks having IP address of 192.168.2.0/26 and 2.64/26 having OSPF and the EIGRP respectively, their internal routing protocol. So we have to make them interconnect with one another. So in my previous videos, when there is only one particular routing protocol, what we have done in the edge router, we let the BGP know the particular internal routing protocol and also let the internal routing protocol as to know the BGP route. So in edge router there was only two routing protocol. One is its internal routing protocol, whether it may be EIGRP or OSPF, and another is the BGP. But in this scenario we have three routing protocol run in the edge router. One will be OSPF, second will be EIGRP, and third will be BGP, and we have to let them know each other. Until and unless they know each other, they can't communicate within itself, and also it can't communicate with the outside world. So for that, let's go to the cluster number 0. So in the cluster number 0, we have to first configure this router 0. So I am bringing the router 0 main screen. Here enable config T, and the first routing protocol is OSPF. So OSPF, let its process ID is 1, and it has two network. One network is 192.168.1.0 with its wildcard marks as 0.0.0.63 in the area 0. Second network is 10.0.0.0 with wildcard marks 0.0.0.3 area 0. Here exit. So I have opened the OSPF routing protocol at the router 0 on the first network domain. So let's go to the router 1. So bringing back the router 1 screen. And yes, so enable config T. Here internal routing protocol is EIGRP. So with ASN number 30, and it has two network 192.168.1.64 wildcard 0.0.0.63, and the another network is 10.0.0.4 with wildcard 0.0.0.3, and no auto summary. So here also I have enabled the EIGRP routing protocol at the router 1, and similarly let's configure for the cluster 1 the router number 5 and router number 6. So bringing back the router number 5 main screen, router number 5, yes. So enable config T. First, this internal routing protocol is OSPF, that says process ID is 2, and having network of 192.168.2.0 wildcard 0.0.0.63 area 0. Second network is 10.0.0.16 with wildcard 0.0.0.3 area 0. So switching off the router 5 main screen, and so let's do the same thing for the router number 6. So router number 6, enable config T, router with EIGRP routing protocol having ASN number of 50 and network having 192.168.2.64 wildcard marks 0.0.0.63. Second network 10.0.0.20 with wildcard 0.0.0.3 and no auto summary. So this configuration of the local routing protocol at each router is finished, but when I try to ping, say in cluster 0, when I try to ping from PC0 to PC1, it won't communicate, because even though I have enabled the routing protocol at their respective router N, at the edge router it has not yet been configured. So let's define for the this at router number 2, edge router of the cluster 0. So router number 2, bringing back the screen of router 2. Yes. Enable config T, then the say router first opening is OSPF process ID 1, its network, then dot 0.0.0, okay, then .0.0.0 with wildcard marks as 0.0.0.3 area 0 and exit, and next is here neighborship has been created, and router EIGRP with ASN number 30 and network of 10.0.0.4 wildcard marks 0.0.0.3 and here also neighborship created and no auto summary. So router number 2, I am switching off the screen, so bringing back the main screen. Here definition of this EIGRP and OSPF are also configured at the edge router, but still the two local routing protocol are unknown to one another. It means EIGRP has no knowledge about the OSPF routing protocol, and similarly OSPF has no idea about the EIGRP routing protocol. Because of that, this PC can't connect with one another, or they can't ping one another. So still let's try to ping from PC0 to PC1. So bringing back the PC0 screen, so ping 192.168.1.66, it will say destination host unreachable, because still at this point the two routing protocol are unknown to one another. So let's do the proper definition for them. For that we have to go to our edge router and we have to let them know one another. So router 2, bringing back the main screen of router number 2, here let's do for router OSPF process ID 1 and redistribute the EIGRP ASN number 30 with subnets. And before I will define the same in the EIGRP. Let's see one thing. The serial port of the edge router to which this in cluster 0 where the EIGRP network is connected, its serial port is 0 SE011. So we just want to confirm this thing. Edge router, what is the bandwidth delay, those things. So for that, so interface SE 0/1/1, it's a serial port, so its bandwidth will be 1544 kbps. Delay should be 20,000 microsecond. MTU 1500. Reliability 255, and the load is 1. So now we can jump into it. Now config T router EIGRP is number 30, and we have to redistribute our OSPF with process ID 1 with matrices as 1544, and the delay, it should be multiple of 10, so it should be 2000. Here is 20,000 microseconds, so multiple of 10 should be 2000. And the reliability 255, and then this load 1, and this MTU 1500. Okay, now since I have uh, let the two routing protocol known to each other, now the this pinging from PC0 to PC1 will work. So let's see. So bringing our PC0 screen, this, so let's do the command again, 1.66, whether it is pinging or not. uh, Now it's pinging. Okay, so the same thing we have to do in the cluster number 1. Cluster number 1 here, I think I have already defined this local routing protocol here. So we have to whether in the edge router also we have defined or not. Edge router, I think in the edge router we haven't yet defined. So we have to go to the edge router 4 of the edge router of the cluster 1. So bringing the screen of router 4, wait, some more screen is opening up. Router number 4, correct na? Wait. uh-huh Wait a moment. Let me define this router 4, R4. Okay, so router 4 is open. So here we have to define or configure the router first. OSPF, let's set a process ID to network. It has is we have to confirm again one thing, whether OSPF is working on which network domain it is on, working on. 10.0.0.16. So network 10.0.0.16 with wildcard marks 0.0.0.3 area 0 and exit, and after this here neighborship has been created, and the router EIGRP with ASN number 50 with its network as 10.0.0.20 with wildcard 0.0.0.3 and neighborship created, and no auto summary. Now similarly, just like in our cluster 0, here also in cluster 1 the PC 2 and 3 can't connect with one another because the two routing protocol which has been configured at the edge router R4 are unknown to each other, so we have to let them know one another. So again, go to router 4 uh, and the router OSPF process ID 2 and redistribute our EIGRP with ASN number 50 with subsets. Exit, and for the EIGRP part which is connected to our serial port 0/2/0, which is serial port, its bandwidth will be same 1544, but still let's see 0/2/0 1544. So config T router EIGRP with ASN number 50 and redistribute OSPF process ID to wing matrix bandwidth 1544, delay 2000, reliability 255, load 1, and the MTU 1500. Exit. Now the two local routing protocol are known to one another, so we can try check our ping test. So in cluster 1 we will check pinging from PC number 2 to 3. So PC number 2 main screen is been brought, and the PC number 2 ping 192.168.2.66. Now it's pinging. Okay, and this back to our main screen again. Now the internal routing within the particular ASN is successful, as I have let the internal routing known to each other, but still they can't communicate outside of its ASN because BGP routing protocol, which is used to communicate two different ASN, is still not yet configured. So pinging from this cluster 0 to cluster 1 or cluster 1 to cluster 0 won't work, but still let's try. So again, going to our PC number 2. So PC number 2, I will try the ping PC cluster 0 PC1, this first PC 192.168.1.2, which is destination host unreachable. So at the BGP router, router 3, we have to bring it, router number 3. So enable config T, and here router BGP, this ASN number is 100, and wait, let me check. Wait, this port has not yet been configured. Its port are not yet been configured, so it's showing this error. So let's configure the port. So exit NTSC serial port 0/1/0 IP address 10.0.0.10 with subnet mask 255.255.255.252, and no shutdown. No shutdown. Wait. .50. Let me do no router BGP 100. Removing the interesting. So again, interface SC 0/1/0 IP address 10.0.0.10 subnet mask 255.255.255.252, no shutdown, and there is INT SE 0/1/1 with IP address 10.0.0.13, and the subnet mask 255.255.255.252, and no shutdown. Now I have enabled these interfaces, but still interfaces is down. That means at the edge router also I have not yet defined the serial port to the BGP router. So its serial port is just SC020, and this also, and this is SC010. So this is SC020. So let's go to the edge router number 2. So router number 2 screen is brought. Enable config t interface se/2/0 IP address as 10.0.0.9 255.255.255.252 and the no shutdown JIT. So switching off the router 2 screen, main screen. Now our link is up. Similarly, we have to do for this edge router number 4. So bringing the screen of router 4, router number 4, so interface SE0/1/0 IP address as 10.0.0.14 subnet mask 255.255.255.252 and the no shutdown. So now we can switch off our router 4 screen. Back to main screen. Now here our port is up now. Now we can go to this BGP router number 3. So router number 3 screen has been brought, and here defining BGP with ASN number 100 and its neighbor as 10.0.0.9 with remote having remote ASN of this 30, and another is the 10.0.0.13 with remote ASN of 50. Here why it is the wait sorry I have done one mistake. It should be 14, not because 13 is its interface IP. Is it? So we can check our configuration here. So IP BGP summary neighbor are 10.0.0.9 and 10.0.0.14, which is correct. So when switch off router 3 screen, back to our main screen. So here at the BGP router we have configured the BGP at the we have defined the BGP neighbors at this corresponding interfaces. Now we have to again configure BGP at the respective edge router. So let's go to router number 2 first. Here router BGP with ASN number 30 is neighbor as 10.0.0.10 with having remote ASN of 100. Now our neighborship has been created. So exit, switching off router 2. Now the next is done is the at the edge router number 4. So router number 4 screen is brought back, and router BGP ASN number 50 and its neighbor as 10.0.0.13 remote ASN of 100. Here also neighborship has been created. Exit. So still at this point, the two clusters can't communicate with one another because here BGP is unknown to the internal routing protocol going on inside, and the internal routing protocol also has no idea about the BGP routing protocol. So at the edge router we have to define, let them know each other. So again, let's go to router number 2. But still, let's confirm again one thing. Let's confirm again. So going back to cluster 0, I will go to PC 0 and try to ping to the cluster number 1 networks. So PC number 0, 202, destination host unreachable. Similarly, we'll check for this 2.66 also, which will also be destination host unreachable. So fine. So at the edge router of the first cluster 0, let's go to router number 2. Bringing the screen of router number 2. So first I will open router OSPF process ID 1 will redistribute BGP being ASN number 30 with subnets. Okay, exit. And also router EIGRP ASN number 30 redistribute BGP with ASN number 30 with subnets. No, subnet is not required. Here I have to put the matrix. Bandwidth 1544, the delay 2000, 255 reliability, load, and the 1500. Exit. And the router BGP, this 30, and have to redistribute here OSPF process ID 1 and redistribute this EIGRP process ID, this AS number 30. So here I have at the edge router of the cluster 0, I have this exchange the routing information between the routing protocols. So let's do the same for the edge router of the cluster 1. So router number 4. So this router OSPF process ID 2 redistribute BGP with ASN number 50 with subnets, and the router EIGRP with ASN number 50 and the redistribute BGP with ASN number 50 having matrices 1544, 2000, 255, 1 and 1500, and the router BGP ASN number 50 redistribute OSPF process ID 2 redistribute the EIGRP process ID 50, this ASN number 50, So here at the edge router of the cluster one also I have led the this exchange of the routing protocols, routing information among the routing protocol. Uh, so I think the network will work now. So let's go to cluster 0 and try to ping from cluster 0 to cluster 1. So PC 0, I'm bringing the main screen again. PC 0. So now pinging again 2.2. Now it's pinging, and 2.66 is also pinging. Uh, so at my edge router, three routing protocols are working: BGP, OSPF, and EIGRP. And as soon as I have I have done the redistribution of this routing protocols, mean from local routing protocol to this BGP and BGP to this local routing protocol. So because of that, the local IP will know about it when IP and how to go take the traffic to its the exterior to the destination network in different ASN. Similarly, the when IP also know about its interior local IP, how to how to reach to get to the particular destination. So uh, there is a simple this demonstration of a hybrid network which I want to share to you friends. So thank you friends.